For you guys who don't know me, my name is Ebony Williams. I'm the Managing Director of our Gordon Engineering Leadership Center. Thank you all for being here tonight. I know that it comes with a lot of interest for you to be here because it's competing with other things such as schoolwork and other things that we have going on in our lives for you people who are not students that are in the audience. But we're very happy to have you. It's an honor to be doing this event tonight. The lineup is phenomenal. So the Gordon Center has been with the Jacobs School of Engineering for going on 3 years. We're in 3 years. We're entering our 3rd academic year. The program was started to develop engineers into leaders or to help that process. Some of you will naturally become leaders because you can't stand the fact that no one else is stepping up and you want something to happen in the world. With the way that that happens, sometimes you need a little help or we stumble along the way. People who do it without any development sometimes lose their friends or lose the people that they work with because a little more friction that comes out of leading a group of highly intelligent, motivated individuals who want to impact the world. I'd like to also say that we can be a little confrontational and competitive as engineers. I know not you, I'm just talking about me, okay? All that being said, the center is excited to feature, this is one of the several offerings the Gordon Center features. We do forums, we do workshops, we do courses. Tonight you're at an engineering leadership forum, and what we do at these forums is bring people who are in the industry, who are leading engineering projects, who are actually engineers, right? A lot of our companies are now run by lawyers or MBA individuals, but these are engineers who took on the task of learning the other pieces to motivate and push people forward to meet a goal. And what amazing goal we're going to talk about tonight, commercial spacecraft. Space travel. I can't wait. I'm excited to get into the space, and Doug told me that he can make this happen for me. Even if he can't, I'm putting that on him. So if any of you guys want to go with me, let me know. I'm taking a sign-up sheet, and, we can raffle it off. Frieder, you didn't hear any of that. That's the dean. If you don't know, Frieder by Frieder, Dean Seible. Anyway, one of the things that I must say, or I'll get in trouble by our founder, is that we believe that any engineer can solve any problem. So I love that there are people in this room who are not structural engineers or mechanical or aerospace engineers. That never should be a limit. If there's something that you're interested in as an engineer, it's possible for you to contribute to the field and make it possible. If you talk to Mr. Grose when you ask questions, you'll find out that his company hires people from all different backgrounds. The biggest thing is we're looking for technical expertise and drive. So hopefully you'll get some of that. The way the night will go is we'll have a keynote speaker, and then we'll take a few questions for this individual in particular, and then we'll have a panel, and you'll see some of the panelist names are already up there. I promised to introduce. You guys have a special treat. Originally, I wasn't sure the dean was going to be able to moderate our panel, but we have the dean of the School of Engineering here to moderate the panel. I get to sit down. No, I'm just playing. No, but it should be a lot of fun tonight. With that being said, I'm not one to talk for much. I will be up here and down. There's a lot of interaction that we'll have tonight. We expect you to ask questions. We don't bring these people to campus just for you to sit in the audience and just stare. This is a chance for you to talk to people. And the fun part about this is the people who are speaking tonight, we have 2 stellar faculty members, and then we also have 3 panelists, and our panelists are all alumni of UCSD. So what a great chance to talk to people about what are the skills that they were able to take from here and use in the world. What are the things that they would have done differently? How would you, there's tons of things you can ask. You can ask them about what classes to avoid. But be careful, there are faculty in the room, so they may take it personal too, so, Anyway, with that being said, I think I'm just going to get us started because we started a little bit late. And with that, I would like to introduce Doug Grose. Doug Grose works at Blue Origin, and Blue Origin is a company, one of several companies that's in the race for the commercialization of space travel. But we believe that Blue Origin's at the forefront of that. And we believe that we know that tonight you guys are going to get to see some footage that no one else has been able to see. You'll get to ask some questions and find out what are the technical innovations that are having to happen to make this possible? What is keeping Blue Origin at the forefront of this race? And what are some of the things that contribute to that possibility? But anybody who's been to an event that I do knows that I don't let people just come up here and do a technical talk. We love the technology, and that's important, but we're also interested in the journey that it took for the person to be where they are today, because we all, if you left UCSD with the education you gave, we know you can do anything, but there's several different ways to get there. And so I'd like for you to have some exposure to some of that journey with this conversation. So Doug Grose got his BS in structural engineering in 1989 from UCSD, his master's of science from Stanford. He worked with Dean Sibley in the Powell Lab when he was here. And so there's some fun stuff we might see in the panel later with some banter of them knowing one another. He did 15 years at Boeing in Seattle, and we actually overlapped. I did my PhD up there, and Seattle's fun. I know for a fact that he likes to surf. They always say engineers don't do anything, but we all know that's untrue. I know people who do a lot of things, and I love when they say engineers don't talk, because I usually can't get you guys to be quiet. So I'm really confused at where they're getting their data. I think they're not asking you the right questions. And now he's at Blue Origin. I won't go into more about Doug, because he's going to share a few things for himself about that, but we're very honored to have you here tonight, Doug, to give us some exposure to what you guys are doing at Blue Origin and what's possible for UCSD alum and what's possible for us as engineers who are up and coming and where we can play in the world. So with that, please help me bring Doug Grose to the stage.
Thank you very much, Ebony. That was a nice little introduction. I don't know if I'd call it a race for space, because obviously this country's already done some amazing things in space. Around the time I was born, so this is not quite the same. The other thing is there's so few competitors in this race that, and there's really no race day necessarily. And our approach is very different than the other major player in the suborbital space arena, which is Virgin Galactic, helped by Scaled Composites. I want to thank Ebony and Rod and Frieder for inviting me here. I'm totally excited to be here. I'm quite surprised because my company does not talk very often, but I couldn't be happier. I went surfing on Sunday, and that was a lot of fun. And I hope all of you don't take for granted this school, this dean, Frieder Sibley, and I think help me out here. Frieder Sibley's helped me a lot over the years, and I'm deeply indebted to him for inspiring me to become a structural engineer and for helping me get into graduate school and for inspiring me. So thank you, Dr. Sibley. Okay. I also want to thank Larry Berman, who worked with me in the Powell Lab, and he was a great leader. Okay, so let me dive into this thing. This is what I'm going to tell you. So this is a little bit of stuff about me. You already know I went here in '89. Worked a little bit with Blaylock Willis and Associates, structural engineering firm. Yeah, you can keep rolling for this. Basically doing underwater inspections of piers, and that was a lot of fun diving with Al Blaylock. And he was quite a leader. One of the leadership traits I think you should all try to adopt is that you're willing, you know how to do what you're asking other people to do. For example, he was 75 years old when I worked with him, and he would jump off a pier approximately 15 feet off the water in full scuba gear to inspect the piers with us. So he was not afraid to literally dive into the work and get things done. So at any rate, I did pursue mostly a civil path here. At Stanford, I studied aerospace stuff. I then went to the Boeing company and worked in stress methods and allowables, and that's a funny place. Stress methods and allowables was referred to by some of the old-timers as the elephant's graveyard. And when you hear your coworkers calling this place an elephant's graveyard, that's not a good thing. Basically, they encouraged me to get out onto some programs. So I Worked on the F-22 on internal loads, basically NASTRAN codes to pre and post process large models of the F-22 fighter. Then we moved into a stress group where we're actually sizing structure, doing analysis on titanium, aluminum, composite, bolted joints, bonded joints, honeycomb, a variety of interesting structures. Then worked on the X-32 prototype from 96 to 2000. We lost the JSF, Boeing lost it, Lockheed beat us, but we did develop a prototype. You can see a picture on the upper right there, or the middle right, I should say. So that's a short takeoff, vertical landing jet aircraft. My last main work at Boeing was on the P-8 program, which is basically a 737 with a weapons bay, so it can drop torpedoes and sonobuoys. So that's a pretty low-tech program. That 737's been around since 1967, before I was born, so it's still going strong. It's a great airplane. It's boring. Boring is good in engineering, so there you go. Then a friend called me from Blue Origin and said, hey, you should put in a resume. And the work they were doing was obviously pretty exciting. It was very early in the company's history. So at Blue Origin, I've worked on a variety of things, and I'll tell you about some of that. So the cool thing there is that work involves me going back to a lot of the civil work that I learned in school. And fortunately, the program here is ridiculously good. So it's a fun transition to get off of airplanes and rockets and do some basic I-beams and bolted joints and concrete and dirt again. So I enjoy that. You probably know a lot of this. Some would say, well, this is motherhood and apple pie. I'm just commenting on the things that I've seen screwed up over and over again. You know, it's kind of funny. I'm the keynote speaker because I'm not a director or a manager or anything, but I've worked with a lot of them. I've certainly led a lot of projects. I'm definitely more on the technical side than the management side, but I can tell you these are all very good lessons. And the thing is, here's something. You can be a leader in the technical field, and that's great. You don't have to be a bean counting manager. You know, there's paths for success and making tons of money and being very happy if you don't want to be a manager. So anyway, know your stuff. This stuff is really hard. Don't just trust computers. Everybody loves computers. We love to make pretty contour plots. Physics always wins. You know, a quote from an engineer I worked with, John Hammond at Lockheed, was, you know, talk to God. If you don't like the physics, talk to God, because, you know, don't talk to me because I can't change the physics. So I kind of like that. Be stoked. And by the way, I windsurf. I'm a pretty lousy surfer, but windsurfing I'm pretty good, and that is fun. And I do that on the Columbia River, and that place rocks compared to windsurfing here. But you do have better surf, and this weather is just crazy. Find what inspires you and do that. If you're not stoked, passionate about what you do, then you should find something else to do, because there's a lot of cool things in engineering. Now, of course, you know, it's great if you can go be a professional skier or something, but you know, I am talking about in the realm of engineering. But this stuff is fun. I mean, F-18, you know, some of these rockets going to the moon. I mean, this is just crazy stuff, and it's very exciting. It's exciting to me, at least. Communicate effectively. So this is so obvious. Talk to your people. Talk to your colleagues. Give people feedback, and don't just give them good job. I mean, that's important too. But you've got to, if you need help, you've got to ask for that help. If you want somebody to do something, tell them to do it. And maybe some people communicate better with an email or a text, and some people do better with face-to-face. Know what works for different people, and you may do all three or both if you need to. People are different, so you've got to get to know them. Don't just be a machine. Go out to lunch with your boss. Go out to lunch with people who work for you. Talk to them. Find out what makes them tick. Ask them for advice for you. Something really stupid. Units errors. metric versus English units. I mean, come on, this stuff is, why are we even talking about this? And the reason we're talking about it is because we keep blowing stuff up and breaking stuff and not deploying parachutes, and the list goes on and on. So write these things down, communicate them. No verbal instructions. It just happens over and over again. And I say personally too. I mean, husband and wife, boyfriend and girlfriend, friends, assumptions, communicate. Think about it. One word, communication. Safety. I was really impressed with the safety out here on your new building. I mean, we had to wear gloves, hard hat, a vest, and safety glasses. Everybody. If they don't wear one of these, they don't get paid. They have to go home for the day. It's phenomenal, but you know what? It's a good idea, because if everybody has to do it, then you're going to be, there's oh, well, I thought blah, 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 communication again. If you have a simple rule, I have an engineering ring on my finger. This is basically my reminder to not screw stuff up and hurt people. And it's all about safety. Now, there is a difference. In some cases, one of the problems with NASA, I would say, and, well, I'll say with some organizations, they always go with the most conservative person in the room. It's like, well, what about fill in the blank with some crazy lunatic problem that could happen on some crazy combination of circumstances. So you've got to use some judgment here about these things. There's some things that are problems. Hey, that bolt isn't painted blue. Come on. Okay, so stay balanced. Home versus work, where you spend your time at work. You've got a limited amount of time. Time is our most precious commodity, everybody. And I appreciate you coming out to listen to me and our little panel. I hope we can give you something useful, make you think about something. Stay balanced. You're in school. School is freaking hard. It's harder than work. It's ridiculous. It follows you. You're not even done when you get in. If you're a grad student, I mean, your research goes on and on. It's very difficult. Stay balanced. Exercise. Go surfing. You're in freaking San Diego. Learn to scuba dive. I'm serious. Stay balanced. Meditate. Breathe. One of the things I do, this is a little crazy, but I deliberately walk slow when I'm at work. I mean, I work like a demon, and then I get up from my desk and I slowly walk where I'm going. No, it's not like, it's more like, but it's not this. I am not impressed with how stressed out you are. I'm impressed with what good work you do. Nobody's impressed. Think about that. What should impress people? How stressed out you are, or how much good work you do? Trust but verify. Ronald Reagan talking about the Cold War. I thought you did this. I thought Joe installed the safety. I thought you analyzed the composite side of the joint. I thought blah, 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 blah. If it's important, verify it. Write a procedure that goes through it. Test is worth 1,000 analyses. That's the beauty of your program here, Dr. Sibley, is the amazing amount of testing. Of course, analysis is a lot cheaper. Ideally, you like to do a few tests, figure out a good method, and then you apply that to everything under the sun. And the problem is we keep designing different aerospace vehicles and buildings and structures, so we have to vary that a lot. Seek out the best people, but utilize the strength of all. In other words, of course we try to hire the best people we can, but you know what? You end up with some rock stars. In fact, you end up with quite a few rock stars. Don't be a rock star. Now, a rock star is somebody who's too good to do fill in the blank. I don't do drawings. I just do this. I don't do that kind of analysis. I just let them do that. Don't just tell other people what to do. I mean, don't be above doing everything. I mean, obviously you can't do everything yourself, but especially when you're learning the ropes, ask for more responsibility. Don't try to duck out of stuff. We see that quite a lot where I come from. Be proud. I mean, this stuff is cool. We've worked very hard to learn this stuff. The products we're making are outrageously cool. Not just the rockets, but the the improvements in computing and electrical engineering, semiconductors, medicine. I mean, seismic performance of buildings. I mean, well, at least bridges for now. But very, very impressive. The other thing is don't be a cowboy either, and that's the person who basically says, "Oh, it'll be okay, just go for it. Hold my beer and watch this." We have quotes around our building, so some of them are like Mario Andretti. If you're in control, you're not going fast enough. You know, so that's a little questionable. But the hold my beer and watch this is kind of the cowboy. But also a more serious explanation of the cowboy would be somebody who kind of looks at it, you know, without really crunching any numbers, even on an envelope, and says, that should be okay. Just go ahead and lift it. And so, you know, we've dropped stuff because of straps tearing through, because the lifting wasn't well thought out. You just got to be careful. But one of the strengths of a good leader is that you can figure out how to work with a lot of different people. You're going to have cowboys working for you. You're going to have rock stars working for you. And in the end, it's probably a good thing, because you're going to have a diverse workforce, and they're going to bring different things to the table, and you can leverage what they're bringing. And a good manager can deal with each of them. Rotating people through different jobs is good. Document things. Documentation is a horrible thing to have to do, but that's the way we go back and look at things. And I do it because I forget things. I like to be able to go back. So empower your team. Train your replacement. Have other people do stuff and then check the work that they do. That's how you're helping them and you're helping your organization. Know when to stop. I mean, engineers love to improve things. The simplest design. One of the cool lessons that Dr. Sibley taught me, we were trying to stop a crack from growing in a beam out in the lab. And he said, "Hey, Doug, you know, figure something out how to post tension this thing." So I came up with some silly thing that was going to require a bunch of manufacturing operations. Or at least it was going to require a especially large drilled hole. And he said, after I showed it to him, he said, "Well, why don't you just slap this bearing plate on top of 2 tubes and call it good?" It's like, wow, that's great, you know, and I really appreciated that. That example, the perfect part is one that requires almost no operations. Give me a beam that's 10 feet long. That's about as good as it gets. And use an extrusion, by the way. We had an example of a high-paid design house that came in and wanted to hog out an I-beam from a large chunk of steel. It was the most unbelievable thing I'd ever seen. So we basically went back and said, well, wait, we'll use a W section, we'll weld in a few pieces. This kind of thing is just absurd. Simplicity should be your goal in every design, even if it's software or some mechanical device. Now, a lot of times, if you're designing a Mars rover, you're going to have a lot of weird stuff because it's got to unfold and all this. But your goal should be simplicity, not complexity. Make stuff. Know how to tighten a bolt. I have met engineers who do not know how to tighten a bolt. They are not from this school. Now, a bolt is just an example. If you make software or if you make electrical engineering stuff, whatever, control systems, bioengineering, know how to get your hands dirty. Even if your field is very theoretical, make stuff, get into it. If you make control systems, tweak them, play with them. Don't just sit there on the lab and show a cute simulation on the computer. I want to see a movie of your thing working. I don't want to see a simulation. Do that, even in your personal life. I mean, make some furniture, make work on your car, you know, just don't be afraid of that. This is my last slide. I'm going to show you one more video after this. Pay attention to detail. Pick your battles. You don't need to dominate your team and dictate every microscopic little thing that they do. Some hotshots like to do that, and it's kind of alienating to the people that they work for. If you're just using your people, for example, as a voice actuated drafter, that's a very rude thing to do for your designers, for example. Nobody likes to just, you know, hey, go build this part. It looks like this. They give you a piece of paper that shows the part exactly. Then, what am I, a voice-actuated drafter? That's no fun. If you need to make a decision independently, make the decision as if it's your company. If you want to know if are you doing the right thing? Now, I'm assuming good intentions and so forth. It's your company. You want it to succeed. You decide what the decision should be. If you have to decide, I mean, a lot of times we're told what to do, but if you have some judgment calls to make, that should be your criteria. Of course, you have to be realistic with your budget scheduling and staffing. Don't either over or under do that. It's very, very difficult to do. We struggle with schedule. And don't limit yourself. Obviously, you will. Don't be the one to say, you know, wow, that's too hard for me, or I can't get that job. I'll never get that job. That's not the way to go. Okay, so I'm going to show you one more video. Now this one's from the pad. So could you turn your camera off now?
We have time for us to take 1 or 2 questions to Doug specifically. Is there anyone who has a question they'd like to ask the person who's shown us secret videos? Any questions? Sure. Hello, hello.
I worked in space for 40 years. I worked on the Apollo. I worked on the team that initially sold the Apollo to President Kennedy. I worked on the space shuttle. And the question I have for you is, who is your market today? And how do you sell that? How do you promote that?
Well, I think for the near term, we really aren't thinking about that, and we're not worried about that. We're trying to develop our products and get them working properly, and we really aren't worried about that. Now, down the road, we do hope to be selling tickets for suborbital tourism, and actually, everything we do, down the road, we would be comfortable marketing that to whoever is interested in. Now, well, we're not going to break any ITAR, terrorist countries type of thing, but if you want to get a payload up, we would certainly, entertain that down the road. We're working on vehicles that we think are useful, and whether or not they would serve, they're not going to be. We're kind of focusing on what we want to do, and if something comes along that fits in obviously this stuff, as you obviously know far more than I'm sure, is it's very specific to how much payload you want to get up there and what orbit you're talking about. We're not limiting ourselves on any particular orbit or future. We are very, very long-term, decades. Our planning is decades type of planning. So we're not so worried about trying to fit a particular government contract or anything like that.
What is your maximum ticket?
Did you say G? Well, it depends which vehicle you're talking about. That first New Shepard was the egg-shaped thing. That was ridiculous. It's almost absurd to even talk about it. The second one took off with a thrust to weight of about 1.2, and obviously it increases from there. That one was going to go to about 50 miles or so. It got up to about 60,000 feet before we had that controls issue.
The question he just answered.
We run trajectories on everything.
The question he just answered was, what was the G load for takeoff for the different vehicles that he showed us today? Next question.
Good evening. My name is Diallo Wallace. I'm from State War headquarters here. And first of all, I think it's really incredible what you all are doing there with Blue Origin. And as much as I would like to go down the techie geeky road with you on this, I'm also interested in the managerial part. And the question that I have for you is from, I guess, an integrated master schedule standpoint. Your level of effort, are you seeing a lot more level of effort from a programmatic side or from the technical? Because you said that there was only 170 people there, so I'm assuming that you're wearing multiple hats at this organization. So my question to you is from a program management standpoint, where do you see the majority of your level of effort going towards?
Doug, let me repeat before you answer. So the question was, managerial standpoint, where are your efforts going with a company of 170 doing as much as you saw presented with all the different pieces that are there? Where does your effort go towards? Is it mainly technical, or is it towards some of the logistics or business side of the house? And are you wearing multiple hats?
We wear a ridiculous number of hats. We have to, I mean, I do analysis, I run finite element codes, I buy things, I make purchase orders, I talk to contractors, I inspect stuff in the field, I talk to designers, I test materials, either myself or I send them out. I go through the data, develop allowables, develop external loads, develop internal loads, lead a few little research projects on the side, help interns, mentor people. That's just me. I really don't like the schedule and budget stuff so much. I like using Excel or a piece of paper and saying, here it is, let's do it. It's a very difficult problem. We struggle with schedule big time, and we have one schedule guru, and basically he has people put in their own stuff. So there's an overhead burden that is on our time to enter that. I mean, schedule is certainly important. I like to keep it simple. Obviously, that's not quite enough. When you have a big program, you have to really plan it out and say how many people do you need. I don't know if that's an answer or not, but
No, that was a great answer.
it's a big problem. It's tough.
I don't see any other hands immediately. Oh, and then like 4 popped up. So let's think about this. I will take 2 because we have other great people to add to this conversation. And the 2 that I take is the one right next to you. Yep, in the black vest. Yep.
Hi, I'm an undergraduate student studying mechanical engineering, but my question is nowhere related to that. I just wanted to ask, how much do you think a ticket to one of these would cost?
Well, the suborbital ticket right now is 200 grand for that's the Virgin Galactic price. Of course, they're not taking passengers yet. They'll take your money. If you want to go to the space station, I can't remember if it's 20 or 30 million. You'll have to talk to the Russians about that. Although there's certainly some middlemen who are happy to take some of your money. I'll just say that we're going to be competitive. Absolutely, we want this to be low cost. We're using LOX hydrogen, which is pretty economical propellants. We're going to make these vehicles whether we get a customer or not. So,
Love it.
When we're ready for customers, then we'll talk about the price.
I'm going for free. I'm just playing. Right here.
Hello. During your time here, what inspired you to go into structural engineering as an undergraduate?
Dr. Frieder Seibel.
Seibel.
He's awesome. He was giving a presentation out in Revelle, I think, and he talked about the program and what graduates do, and I knew I was going to do some kind of engineering, and he's the man.
That was a quick question, so the gentleman looked real sad, so I'm going to let him go.
Thanks. My name is Alex Finch. I'm a second-year structural engineering student. This is more about the business side. In your experience, you said, a lot of people have a bunch of ideas for, space exploration, but it's who has the money. So I was seeing, it showed that you only had a handful of companies that got funding from, government funding. So I was seeing how much of that is politics, who you know, and how much is it who actually has the best design in your experience?
Good question. Boeing. Bring your Boeing to the...
I mean, there's definitely technical evaluations done of all these things. There certainly are political factors. So that's really awkward. I like to think that NASA's not going to fund anybody who's really not serious about what they're doing. I do believe that's there. They have that intent. Mm-hmm. So, I mean, there are technical evaluations done. And, I mean, I think it's a really good program because it's a very small amount of money, and it's widening the field a bit. It's spreading around. I mean, it's creating more companies which will want to hire people like you. And, I think diversity is good. It's kind of a race and a competition mentality, which is sort of a capitalist thing, but that's what the Russians did with engines, and they're the leaders. I mean, they've developed some fantastic engines back long ago with sort of a competitive mentality. I think NASA's kind of doing the same thing.
Well, Doug, thank you so much. That was amazing. I'd like to correct a few things. Just because you don't lead a group of people and have a managerial title, that's not the only thing that defines engineering leadership. You just listed like 4 or 5 different hats that you hold in order to contribute to the products that are there, and that is what we're about here with the Gordon Center and with the Jacobs School. You accrediting the dean for where you are today. The dean is the one who made sure the Gordon Center was here because these are the values that he embodies. And for our students, did you hear that? Write your units down. Yeah. Why'd you take off 5 points? Because I didn't write my units. Because you'll blow up somebody if you don't write your units. Sorry, that was my little professor hat. I'm going to take it back off. Now, managing director, I'll go back into my role. With that, we're going to move on to the panel. There's plenty of things I could say as far as pearls of wisdom that were said within that talk. I hope you guys were taking notes. If not, we do have some of it recorded. But just some amazing thoughts that just came from the years of experience that you have, and I really appreciate that.